Hello friends, welcome to H2 Academy. In the last lecture, we have completed the discussion on the alternating group. So in this particular lecture, we will discuss about the problems on the symmetric group. So let's start our discussion. So what is given in the question number 1 is that do odd permutation in a symmetric group form a group. Okay, so let us start our discussion. So we have the symmetric group as a set of all the bijections from a n element set to a n element set that form a group under operation composition of function. So the order of this symmetric group is n factorial. This means total n factorial elements are there. So half of the elements, that is n factorial upon 2, these are even permutations, and other half n factorial upon 2, these are odd permutation. Okay, so we have seen in the last lecture that the set of even permutations form a group under operation composition of function, and that group is known as alternating group. But this set of odd permutations do not form a group under operation composition of function, because there will not be any existence of identity element, because there will do not form a group. Set of odd permutations do not form a group because there will not be any identity element. And secondly, we have identity is even permutation. Okay, so the set of odd permutation will not satisfy the basic properties of for being a group. Okay, so group होने के लिए जो basic properties होती है वो उसको satisfy नहीं करेगा, because there will not be any identity element. That's why this odd permutations in a sense do not form a group. So let us understand this with an example. Let us take a symmetric group with 3 letters. We have the elements of S3 as this we have already discussed in the previous set of lectures. So we have identity 1, 2, 1, 3, 2, 3. In S3 we have total 3 factorial elements, that is 6 number of elements will be there. Okay, this is 1, 3, 2 and 1, 2, 3. Total 6 number of elements are there. Okay, so these are odd permutations, and this is identity 1, 3, 2, 1, 2, 3 are even permutations. Okay, so these elements form a group under operation composition of function. Okay, so let us make another set. So we have the alternating group as A3 will be set of even permutations. So even permutations are identity 1, 3, 2 and 1, 2, 3. Okay, so these elements will form a group under operation composition of function. So let us make another set. Name this as B3. Okay, so these are the set of B3 is the set of odd permutations. So let us write down 1, 2, 1, 3, 2, 3. Okay, this is our set. Okay, now let us apply the properties of group under operation composition of function. Okay, so for being a group, what are the requirements? First one is closure property. Okay, second one is associativity. Okay, third one is identity element. Identity is unique identity element, or fourth one is existence of inverse for every element. Existence of inverse for every element. But in this particular set there is no identity element. Okay, identity element है क्या? नहीं है. No identity element. Okay, let us apply the closure property. Let us take these two elements 1, 2 and 1, 3, and let us multiply this 1, 2 times of 1, 3. Okay, this means let us do the multiplication. So 1 goes to 3, 3 goes to 3. 1 goes to 3, 3 goes to 3. Now 3 goes to 1, 3 goes to 1, and 1 goes to 2. 1, 3, 2. So this 1, 3, 2, 1, 3, 2 does not belongs to B3. ओके, सो द क्लोजर प्रॉपर्टी सेटिस्फाई नहीं हो रहा है, आइडेंटिटी एलिमेंट भी नहीं है, दैट्स वाई दिस सेट ऑफ ऑड परमुटेशंस डू नॉट फॉर्म ए ग्रुप अंडर ऑपरेशन कंपोजिशन ऑफ फंक्शन. Now let us discuss question number 2. Okay, in question number 2 we have beta is equal to 1 2 3 times of 1 4 5. Okay, so write beta to the power 99, we have to find beta to the power 99. Okay, ये निकालना है. So let us do the multiplication. So we have, let us start the multiplication in this particular direction. So we have 1. So we have 1 goes to 4 and here 4 goes to 4. Now we have 4 goes to 5 and 5 goes to 5. Now we have 5 goes to 1, 1 goes to 2. Now we have 2 goes to 2, 2 goes to 3. Okay, so all elements are there, 1 2 3 4 5. Okay, so beta is nothing but a 1 2 3 4 5 cycle. Okay, so order of beta is equal to length of that cycle 5. Okay, so we have studied that order of a permutation is length of that cycle. Okay, so यहाँ पे क्या है, ये 5 साइकिल है ना, तो लेंथ ऑफ बीटा क्या हो गया, 5 हो गया. सो ऑर्डर ऑफ बीटा क्या हो गया, 5 हो गया. दिस मीन्स बीटा टू द पावर बीटा 5 is identity. Okay, so let us apply a power of 20. So beta to the power 20 is equal to identity to the power 20. So identity to the power 20 is nothing but identity. So beta to the power 100 is equal to identity. Let us multiply beta inverse both side. Okay, so we have beta inverse beta to the power 100 is equal to beta inverse identity. So something beta inverse times identity is beta inverse. Okay, and this is beta to the power 99 is equal to beta inverse. So we have the value of beta is equal to 14523. So beta inverse will be, we have to apply right from this particular direction. So this is 32541. So this is equal to 32541. Okay, so we beta to the power 99 in the cycle form we have to write. So this is 32541. Okay, now let us discuss question number 3. Okay, so now let us discuss question number 3. So we have the value of beta as beta is equal to 1357986, and we have 2 4 or 10. Okay, so we have, since these are disjoint cycles, in disjoint cycle there are no elements in common, so these are disjoint cycle. Okay, so order of beta will be equal to LCM of these cycles. So this is nothing but 7 cycle. 7 elements are there, 1 2 3 4 5 6 7, and here 3 elements are there, 2 4 and 10. So LCM of 7 and 3, this is equal to 21. This means order of beta is 21, so this means beta to the power 21 is equal to identity. Okay, and we have to express n in this particular fashion. So let us multiply beta to the power minus 5 both sides. So beta to the power minus 5 times of beta to the power 21 is equal to beta to the power minus 5 times of identity. So something times of identity is that value, so beta to the power minus 5. So we have this as beta to the power 21 minus 5, this is 16, is equal to beta to the power minus 5. On comparing this with beta to the power n is equal to beta to the power minus 5. So we have n is equal to 16. Now let us discuss question number 4. In question number 4, in S3 is symmetric group with 3 letters. Okay, find the element alpha and beta so that alpha mod is equal to 2, beta mod is equal to this means alpha, order of alpha is 2, order of beta is 2, and alpha beta. Order of alpha beta is 3. Okay, so let us find this. So let us write down the elements of S3. The elements of S3 we have already discussed in previous set of lectures. So S3 is equal to all the bijections from a n element set. Sorry, all the bijections from 3 element set. Do a 3 element set that form a group under operation composition of functions. So S3 is equal to identity element 1 2 1 3 2 3 1 3 2 or 1 2 3. Okay, so these are the elements. Okay, let us take, let alpha is equal to 1 2. This means alpha mod is equal to 2. Beta is equal to 1 3. This means beta mod is equal to 2. Okay, let us multiply alpha beta. Alpha beta is equal to 1 2 times of 1 3. This is equal to, let us do the multiplication. So we have 1, start from 1. So 1 goes to 3, 3 goes to 3. 3 goes to 1, 1 goes to 2. And we have 2 goes to 2, 2 goes to 1. So this is closed. So alpha beta is nothing but a 3 cycle. So alpha beta mod is equal to 3. Okay, so we have in S3 find the element alpha and beta so that alpha, order of alpha is 2. Okay, order of beta is 2 and order of alpha beta is 3. Okay, so we have the elements alpha as 1 2 and element beta as 1 3. Okay, now let us discuss question number 5. Okay, so here we have, these are the representation of permutations in array form. Okay, so let us write down here. So we have in A. Okay, let us write down in the cycle form. Okay, so we have this as 1 goes to 2. Let us start from 1. So 1 goes to 2, 1 goes to 2, 2 goes to 1. So this is closed. Now we have 3, start from 3. 3 goes to 5, 3 goes to 5 and 5 goes to 6, 5 goes to 6 and 6 goes to 3. This is closed and we have this as 4 goes to 4. Okay, so we have 1 goes to 2, 2 goes to 1. Now we have 3 goes to 5, 3 goes to 5 and 5 goes to 6 and we have 6 goes to 3. This is closed. Now we have 4 goes to 4. So these are disjoint cycles. So order of let us take this as alpha. Okay, so order of alpha will be, let us take this as alpha, this permutation as alpha. So order of alpha will be LCM of length of this cycle. So length of 1 2 is 2, length of 3 5 6, this cycle is 3 and length of this is 1. So this is 2 3 and 1. So this is equal to 6. Okay, so what is the order of each of these permutations? So order of this one is 6. Order is equal to 6. Okay, now let us discuss this one. Let us take this as beta. So we have beta is equal to, so here 1 goes to 7, 1 goes to 7. Now we have 7 goes to 5. Now we have 5 goes to 3. Now we have 3 goes to 1. This is closed. Now we have start from 2. So 2 goes to 6. 2 goes to 6. Now we have 6 goes to 4. And we have 4 goes to 2. So this is closed. So this is cycle of length 4. This is cycle of length 3. So order of beta is equal to LCM of 4 and 3. This is equal to 12. Okay, now let us discuss question number 6. What is the order of product of a pair of disjoint cycle of length 4 and 6? Okay, so this is nothing but order of a product of disjoint cycles. Okay, so let us take a cycle of length 4. Cycle of, let us take alpha as cycle of length 4. Okay, so let us take alpha as A1, A2, A3, A4. Okay, now we have let us take beta, cycle of length 6. So we have beta is equal to B1, B2, B3, B4, B5, B6. Okay, so order of alpha will be 4 and order of beta will be 6. Okay, so order of alpha beta is equal to LCM of 4 and 6. So this is equal to 12. Okay, this will be equal to order of alpha beta will be LCM of length of these cycles. Length of cycles 4 and 6. So LCM of 4 and 6 will be 12. Okay, so this is all about the question. So we have discussed up to question number 6. So we will discuss further questions in next particular lecture. Thank you.